Good morning, children, and come back to next topic of the chapter, polynomial. Yesterday we had done what is zero of a polynomial, that is ZERO of a polynomial, and also we had done one division of a polynomial by a linear polynomial, right? Let me again recall the division and do the division again. A simple division let me take. Okay, divide px, that is by x minus 1. This is a linear polynomial. Let me do the division. So as you know, yesterday I had told you how to do division. I'll do the division without much explanation. Change the sign, cancel, then 3x, this is a cancel, and we get 3x plus 5, then plus 3x minus 3, and we get the remainder 8. So children, here you see that the remainder, let us give focus to the remainder. The remainder is equal to 8. To find the remainder, I have done such a big division. You will find that whenever when a polynomial is divided by a linear polynomial, this linear polynomial is 0. Let us find 0 of x minus 1 is 1, right? And let us find of p of 1 now. P of 1 is 1 cube. You know what is p of 1 now? Replace x by 1 and 1 square plus 5. What you get? 1 plus 2 plus 5, and that is also 8. So you find very interesting here that the remainder of this polynomial, without doing such long division, you can find the remainder by just substituting the 0 of the divisor into the polynomial. We have found the p of the 0 of the divisor. P of 1 we have got 8. Let me come back to yesterday's problem again. See children, yesterday this division I had done such a big polynomial x to the power 4 by x minus 2, and I got the remainder 35, right? So what such a big division we have done. Now instead of doing such a big division, let us find out the 0 of x minus 2. ZERO 0 of x minus 2 is 2. So in this polynomial px, if I substitute in place of x2, that means if I find p2, I get a 2 to the power 4 into 2 cubed and so on, and when I simplify, I get the answer as 35, and in this long division also I got the answer as 35. So children, to find out the remainder, there is no need of doing long division, right? We can directly find out the this one by using the remainders theorem. And the remainders theorem says that if px be any polynomial of degree greater than or equal to 1, that means this is a px, okay, and let a be any real number, a here is 1, and if px is divided by the linear polynomial x minus a, then the remainder is pa. Simple. So children, now see, this is a question I have taken. Find the remainder when this polynomial is divided by 5 plus 2x. You can see that 5 plus 2x is also a linear polynomial. So there is no need of doing the whole thing. What we will do, let us find the 0 of 5 plus 2x, which is we have to solve this linear polynomial equation, and you get as minus 5 by 2. So 0 of 5 plus 2x is minus 5 by 2. Now what to find out the remainder? of this px, what we will do is, we will, without doing division, we will substitute in place of x minus 5 by 2. So what you get? Minus 5 by 2 the whole cube, 3 into minus 5 by 2 plus 3 into minus 5 by 2 plus 1. And this, when we solve it, we get minus 125 by 8, and this 75 by, this is a square, 25 into 3, 75, and minus 15 by 2 plus 1. And when you find the LCM, these all things are simplification which everybody will be knowing it. 7th standard and 8th standard you have done it, right? And what you find, 150, and this, it is nothing but minus 27 by 8. That's all. So children, without doing the long division, we have found the remainder just by substituting minus 5 by 2 in the polynomial. So this is a very simple method. But no need of learning by heart this theorem. You should understand that a polynomial, when it is divided by a linear polynomial, you can find the remainder by using remainders theorem. Next, factor theorem. Nothing. It is simply remainder theorem only. If the x minus a will be the factor of the polynomial px if pa is equal to 0. We all know that whenever the remainder is 0, then it is a factor. So if pa is equal to 0 implies that remainder is 0. Remainder is 0 means x minus a is a factor. Let me take an example. Determine whether x minus 2 is a factor of this. So we will take this polynomial and we will substitute p of 2 because the 0 of 2, x minus 2 is 2. So, and what you find, 8 plus 8 minus 16, and you got 0 answer. Very nice. P2 is equal to 0. Then you will write, since P of 2 is equal to 0, therefore x minus 2 is a factor of x cube plus 2x square minus 8x. I hope you understood. Very simple. This is a polynomial. To find out whether it is a factor, we will find the remainder. The remainder is 0, then it is a factor. If the remainder is not equal to 0, then you will write that x minus 2 is not a factor. Same concept with different type of problem. Find k if x minus 1 is a factor of this. Okay, here we have to find the value of this unknown number k. It is already given that x minus 1 is a factor. You have to write, since x minus 1 is a factor of px, therefore p of 1 is equal to 0. In the beginning itself you have to write it is equal to 0 because already it is given that x minus 1 is a factor. So now p of 1 will be nothing but 2 into 1 square k into 1 plus root 2 is equal to 0. Again you will write. Now this is 2 plus k plus root 2 is equal to 0, or you can say that k is equal to 2 will come this side, minus 2 minus root 2. If you want, you can take p minus common and you get this as the answer. So here we are finding the value of k when x minus 1 is already a factor. Here we are determining whether it is a factor. For that we will not put equal to 0 in the beginning. We will solve it and find out whether it is equal to 0. So that's all for today. So today you have learned remainder theorem, factor theorem. No need of learning the theorem. Understand the theorem. The remainder theorem is nothing but to find out the remainder. Factor theorem to find factor, and that is possible only if the remainder is 0. So based on this, today I'll give the problems. It is from the exercise only. Those who do not have textbook, I'll send the questions, and please be thorough about it, and from tomorrow we will be starting factorization. Okay, thank you and have a nice day.